Right, well, hello Algebra 2, Honors Algebra 2. We are going to be starting Unit 10 now. So this is our third week back since we came back from spring break. And this is really kind of the last unit that you really need to make sure that you get through. So we're going to be going through, this first video is going to be about graphing sine and cosine. And then we'll talk about tangent as well as some of the other trig ratios that we saw in the previous unit. So it's very important going into this unit that you have a good understanding of what we were talking about last unit. So if you need to go back and review anything, make sure you do that before you start this one. Also make sure that you've got your unit circle handy. We're going to be using that really closely in this first section of notes especially. And then I've got some more information on that unit circle quiz that I was kind of mentioning in prior weeks that I'll have in a separate video for you guys. So that being said, let's get into it. So 10.1, graphing sine and cosine. So the first thing we're going to do is we're just going to kind of go old school with this, and we're going to go ahead and fill in this chart. So think of it as like an XYT chart. So for X, that's going to be our angles. And then for our Y values, that's going to be either our sine or cosine. Now to get those sine and cosine values, you're going to have to use your unit circle, or at least that would be the easiest way to do it. So as you fill these in, shouldn't be too hard to do. Remember, sine is your Y values, and cosine is your X values. So really all you should have to do is starting at your first point, so starting at 0, you've got a Y value of 0. You should be able to just copy in the Y values going all the way around. I'm going to go ahead and do that now, and you can do the same. So 1, radical 3 over 2, square root 2 over 2, 1 over 2, back down to 0, and then we go negative. So again, you're just copying the Y values down, going all the way around your unit circle. Okay. And then for cosine, we're going to do pretty much the exact same thing. The only difference is on our unit circle, cosine is going to represent the X values. So we're just going to do the same thing. We're going to go all the way around the unit circle, copy down all those X values. So starting at an angle of 0, we would have an X value of 1. And then at pi over 6, X value is radical 3 over 2. And then square root 2 over 2. And then, let's see, 1 over 2 to 0, and then we go negative through those. Okay, cool. So I think we've got those filled in. Now we're going to go ahead and graph all of these values. So in order to graph those, it's going to probably be more useful to know the decimal approximations for all of these. 1/2 is pretty easy. Hopefully you can remember 1/2 is 0.5. As a decimal, square root of 2 over 2, if you type that into your calculator, you should get that is approximately, let's see, I'm typing it in on my own, 0.707. And then lastly, square root of 3 over 2, it'd be good to have that as a decimal as well. Which comes out to 0.866. Okay, so we're going to go ahead and graph each of these two functions. Let's go ahead and start with graphing the sine curve. I'll go ahead and do that in purple here. So sine will be purple. And it looks like we've got X values, as well as we'll use the sine values for the Y values. So our first point would be at 0, 0. Our next point would be at pi over 6. So if you're looking at our graph here, we've got pi, and in fact, I believe we're actually counting by pi over 6. So this would be pi over 6, 2 pi over 6, or pi over 3, and then so on. So the only one we don't have is pi over 4, so that'll be kind of halfway in between pi over 6 and pi over 3. So at pi over 6, we're at 1/2. Let's make this all the way up here 1 and negative 1. So 1/2 would be right here. And then at pi over 4, we're at square root of 2 over 2, which we said as a decimal was 0.707. So if you're thinking about where that would be, this would be 0.75. So it would be just a little bit less than that. So we'll put our point just a little bit below that, halfway in between. And then at pi over 3, we're at radical 3 over 2, which we said was about 0.866. So about right in here. Excuse me. Okay. And then at pi over 2, kind of an easy one. So there we're right at 1. And then we come back down at approximately the same values. So it's a little bit easier once you've gotten it started. Here are those values. And at pi, we're back down at 0. Okay. So now we're graphing essentially the same numbers, just going negative. So our next one is at negative 1/2. So that would be right here. And then we've got negative radical 2 over 2. And then we've got negative square root of 3 over 2. And at 3 pi over 2, you should be at negative 1. And then the easy thing is probably just to reflect those going from there. Go ahead and plot those in. And you should end up with a graph that looks something kind of like this. And so you can probably already see what kind of shape this is going to take. It's going to take on the shape of what's called a sinusoid. And it's kind of this curved, kind of S-shaped graph that looks something kind of like this. And obviously, we're only graphing part of it. It does continue forever in both directions. So don't think that this is the only part of the graph. In fact, if you notice, I've added the arrows on the ends of the graph to indicate that it does continue forever in both directions. Okay, let's do the same thing for cosine. So for cosine, I'll just use a different color. I'll use pink instead. So with cosine, we're going to actually start at 0, 1. I'm going to use the same labels here. So we're going to go up to 1, down to negative 1. And then from there, we're going to be at square root of 3 over 2 next. And then square root of 2 over 2. And then at positive 1/2. And then at pi over 2, we're down at 0. So we're just, again, using the x values are the same. The y values are the only thing that have changed. But we're actually already going to be in the negatives now. So we're going to be at, let's see, 2 pi over 3 and negative 1/2. And then at negative square root of 2 over 2. So somewhere about here. Negative square root of 3 over 2. And at pi, we're at negative 1. And then we can reflect those. If you want to think about it that way, it'll make the rest of the graph actually go pretty quick if you reflect all those points. Kind of follow that same points but going the other direction now. And you should end up with a graph that looks something kind of like this. So again, it's got a similar shape. It's just kind of starting at a different point. Instead of starting kind of in the middle of it, it's kind of starting at the peak of the graph. And then it's continuing from there. So it's the same basic idea looking at each of these graphs. The only difference being kind of where you start the graph. So let's do this. Let's talk about some of the key features of these graphs. Starting with domain and range. So the domain, like we said, you could continue this forever in both directions. If you think about it, you could continue to kind of loop around your unit circle. So your domain is going to be all real numbers or negative to positive infinity. The range, though, is a little bit more limited. If you notice, the smallest value you can get to is negative 1, and the largest value you can get to is positive 1. Now, both of those are included values, so I'm going to go ahead and use these square brackets to say that we can include those. Okay, some of the other key features of our graphs. The midline is going to be the horizontal line in which the graph of our periodic function oscillates. A good way to think about this is that it's the horizontal line of symmetry. In both of these cases, that line, which I'm drawing in red here, would have been through y equals 0. So if you draw your line through y equals 0, and if you were to continue your graph, you would have this kind of reflective symmetry about that line. So if you wanted to mention for the parent functions, that's about the line y equals 0. Okay, next is the amplitude. The amplitude is 1/2 of the difference of the maximum or minimum value of the graph of a trig function. Another way to think about amplitude is that it's the distance from your midline to a maximum or minimum. So if you go from your midline up to a maximum, here we had a distance of 1, Here we also had a distance of 1. So even if you're going negative direction, it's still a distance of positive 1. So amplitude will always be a positive number. And so you can see in both of these cases, for our parent function, the amplitude was positive 1. The period is the horizontal length of each cycle of a periodic function. And a cycle is the shortest repeating portion of the graph. In both of these cases, we were able to actually graph one period. So one period started at 0, and then it would have started repeating after 2 pi. So think about the unit circle, how once you go around one time, all the values are going to be the exact same. They're just going to keep repeating. And actually, if you think about it, that's the case for both sine and cosine, is that your period, the length and the distance that it takes to repeat is a distance of 2 pi. Okay, so those are some of the key features. We're going to use those in just a little bit to talk about graphing these by hand and hopefully not having to fill out that table every time we do it. Before we do it, let's just kind of refresh ourselves on transformations. This would be a good chance if you wanted to practice those, to pause the video and see how much you remember. I've got 6 problems that we're going to go through, and I'm going to go through them pretty quickly here. So if you need to pause the video to work through them first, feel free to do that. Okay, so on number 1, we've got 2 transformations. We should have said vertical stretch by 3. We should have also said that it was shifted up by 10. Number 2, we should have had 3 transformations. We should have been reflected, and not over the x-axis, but over the midline. Now in this case, the midline is y equals 0, so it is the x-axis, but you have to be careful because it won't always be that way. The next thing we're going to talk about is the 2. We still would have had a vertical stretch by 2. And then our minus 5 would have been shifted down by 5. So actually in this case, our midline wasn't through y equals 0. It was actually shifted down through y equals negative 5. So then you were really reflecting over that line. So you could have also said, instead of reflected over the midline, reflected over y equals negative 5. So a couple different ways that you can say that. So I'm going to kind of put that in parentheses. And we'll talk a little bit more in just a little bit about how I knew that that midline was at y equals negative 5. Number 3 should have been pretty straightforward. This is just a vertical shrink by 1/2. On number 4, we've got kind of 3 different transformations, very similar to number 2. We were going to be reflected over our midline, which again is going to be different from the x-axis. This time our midline was y equals negative 3. So again, I'll share with you how I knew that in just a little bit. The next thing is that we did have a vertical stretch, and that was by 3/2. And lastly, we were shifted down by 3. Okay, on number 5, we have 2 different transformations. The first is inside the parentheses, so rather than being a vertical, it's going to be a horizontal stretch or a compression. Always think opposite, so horizontal stretch by, and then take the reciprocal. The reciprocal of 1/4 would have been a horizontal stretch by 4. And then one other transformation on this one would have been down by 3. So, if you didn't get number 5, be a good time to pause the video and see if you could get number 6, because I'm going to guess if you missed number 5, you probably also missed number 6. But on number 6, 2 transformations. The first one inside the parentheses. Again, think opposite. So we've got horizontal shrink by the reciprocal of 2. And so the reciprocal of 2 would have been a horizontal shrink by 1/2. And then up by 9 would have been the other transformation. Okay, cool. So let's talk about how I knew what the midline for each of those was, and then we'll also talk about how you can find the amplitude and period by looking at the equation. So regardless of whether you're looking at sine or cosine, these work the same for both, is that your midline is going to be through y equals m. So whatever your vertical translation is, whether you shift it up or down, that's going to determine where your midline is. Next is your amplitude. So your amplitude is going to be whatever your stretch or compression was. And then lastly is going to be your period. This is the one that's probably the least direct. Notice that we have a formula for that. So our period is we're going to take 2 pi divided by the absolute value of b. Okay, So let's talk about how we can use those to make graphing quite a bit easier than what we did at the start of this video. So for the next 3 examples, we're going to identify the transformations and what we're going to abbreviate MAP, so the midline, amplitude, and period, and then we're going to graph each function. So first off, transformations. There are 2 transformations here. We've got a vertical stretch by 3, and we've shifted up by 4. Okay, so the midline, we'll start with that first. It's going to be through y equals whatever your up or down movement was, so y equals 4. Amplitude is the number in front of sine or cosine, so that would mean that our amplitude would be 3. And then our period is going to be 2 pi divided by the number in front of x. And if there is no number in front of x, we'll just assume it's a 1, so we'll go from 0 to 2 pi. So here's what's kind of nice. Here's how you can use that information to help you graph this function. First off, for the period, that's going to tell you how to label your x-axis. Is that we're going to go from 0 to 2 pi, and then if you want to think about how that would be split up, halfway would be pi, halfway of that would be pi over 2, and then 3 pi over 2 would be your halfway between pi and 2 pi. Our midline, I like to draw that in almost as if it's an asymptote. So 1, 2, 3, 4. And so here would be our midline through y equals 4. And then our amplitude is going to tell us what values we're going to go between. So we're going to go from our midline either down by 3 or also up by 3. So I'm going to add in a few extra tick marks above that to illustrate kind of how that's going to work. Now, to make graphing easier, here's what we need to understand, going back to our original 2 graphs, is to try to remember all of these points is going to be very difficult to do. Here's what I would recommend. Let's just use the easy points. So when I'm talking easy points, I'm talking about where we've got like 0 and 1s. Those are going to be some easy points to graph. So I'm looking like right here, right here, right here, and so on. Now these aren't necessarily going to be the exact same points. What they are going to allow us to do is to focus on kind of where are our points that are on the midline versus where are our points that are either up or down by an amplitude. In other words, instead of graphing all of these points, and there's a lot of them, we're going to cut that down to where all you really need to graph is 5 points. Now, to kind of clear up some other things, notice that for sine starts at your midline. So sine starts at the midline, whereas cosine starts at an amplitude. So that's an important thing to understand when you're getting ready to graph either of these. Okay, so going back to our example we were just working on. In this case, we have sine. What that means is that our first point is going to be on our midline. Now from that point, we're going to follow the exact same pattern. So notice that from our midline, so starting at this point here, we went up by 1 amplitude, down by an amplitude, down by an amplitude, up by an amplitude. So let's do the same thing here. Starting from our midline, we're going to go up by an amplitude, down by an amplitude, down by another amplitude, and then back up by 1 amplitude. And then from there, you should have all 5 points that you'll need in order to create your graph. So here that is. And then just make sure that you draw in that that would continue in either direction. All right, so that gave us a chance to talk about sine. Let's talk about cosine. So let's talk about how cosine is a little bit different. Let's start it the same way though. So let's start by listing off our transformations. So we should have 2 of those. We've got a vertical shrink by 1/2, and then we're shifted up by 4. So again, kind of going through and filling out this MAP. So your midline, amplitude, period. Midline is your vertical translation. So y equals 4 once again, same as last time actually. And if you wanted to go ahead and draw that in, that would be an easy thing to go ahead and add to your graph right now. Second thing, amplitude is a little bit shorter this time. Notice the amplitude is just 1/2. So we're going to go up by 1/2 and also down by 1/2. So it's going to be a much shorter graph, which should make sense because it's been vertically shrinked. And then from there, we also need to fill in our period, which again would be 2 pi divided by the number in front of x, which once again was a 1. So it turns out our labels are going to be the exact same. In fact, I'm not going to label all the in-between ones. You can just copy those from above. Now here's where this one's going to start a little bit differently. Notice that this time, cosine actually starts at an amplitude. And then what it does is it goes down twice, up twice, which is really what sine does. It just starts in a different place. So if you think about what would happen on sine if you were to go through it, we started by going up once, down twice. If you continue that, you'd be going up twice, and actually the graph would almost from there kind of follow cosine, where it would go down twice, up twice. So really, cosine and sine are pretty much the same graph. It's just whether or not you started an amplitude or whether you started the midline. So in this case, for cosine, I'm going to have to zoom in a little bit here. We're actually going to start at an amplitude, which again is just 1/2 above 4 and then below 4. So from that amplitude, we're going to go down by 1 amplitude, so you're at midline, then down by another amplitude, up by an amplitude, up by an amplitude. And so this one's going to be kind of hard to show, but very, very, very kind of narrow around that midline. Okay, so we've seen sine, we've seen cosine. Those are the two that we're focused on today. I'm going to go through one more example just to show you what happens when your period is something other than 2 pi. And then I think that's all I've got for you guys. So on number 3, we've got f of x equals sine of 1/2 x plus 3. So starting with our transformations, we're going to start with a horizontal stretch by a factor of 2. So if you think about what that would mean, what that should mean is that instead of going 0 to 2 pi, if you double that, we should be going from 0 to 4 pi. And we'll see if that's actually the case in just a little bit. The other transformation is that we are going to be shifting it up by 3. All right, so midline, let's start with it. We were shifted up by 3. That means midline is through y equals 3. And again, if you want to go ahead and draw that in your graph, that would be great. Okay, amplitude this time. There was nothing in front of sine or cosine, in this case sine, so we'll assume it's a 1, so our amplitude would be 1, so we'll be going up and down by 1. Lastly, period. We're going to take 2 pi divided by whatever number was in front of x. So 2 pi divided by 1/2. So dividing by a fraction, remember, same as multiplying by the reciprocal. And that does in fact lead us to what we kind of expected in the first place, which is that it should be going from 0 to 4 pi. So then labeling these in between values, halfway between 0 and 4 pi would be 2 pi. Halfway in between 0 and 2 pi would just be 1 pi. So we're counting pretty easily: 1 pi, 2 pi, 3 pi, 4 pi. Okay. So in this case, because we've got sine tells us that we're going to start at our midline. And then what we'll do is we'll go up by an amplitude, down by 2 amplitudes. And then if we wanted to continue, we'd go up by 2 amplitudes. In this case, we've only got space for 1 more. And then we can go ahead and draw in our graph between those points. Okay, so that about does it for our graphs today. The only thing I wanted to mention to you all that we haven't gotten a chance to talk about earlier in this section is this idea of what's called a phase shift. If you notice, none of our graphs, we talked about moving left and moving right. That'll actually be something we'll talk about in the next section of notes. But just to give you a definition for that, a phase shift is what we call a horizontal translation of a periodic function. So tomorrow or next video, we're going to talk about moving graphs left and right. And when we do, we're going to call that a phase shift. All right, that's all I've got for you in this first video from Unit 10. Like I mentioned, next section, we're going to be talking a little bit more about how you can go from a graph to the equation. And we'll use phase shifts to write it not only for one equation, but for both sine and for cosine. All right, have a good one, guys.